Hello, today Luke
Isaac.
And Georgia.
will be discussing ETC and chemiosmosis. We will do this by explaining the steps to create 32 to 34 ATP through the multiple steps in this process. After creating the ATP, it will then combine to 2 ATP from glycolysis process and the 2 ATP from the Krebs cycle. From here, it will then be used as cellular respiration for plant and animal organisms.
In the inner membrane, the NADH from citric acid cycle drops off electrons in the inner membrane space, and its hydrogen is given off in the matrix, which creates NAD+. The high-energy electrons jump from protein to protein, giving off energy, while FADH2 gives off its electrons and hydrogen molecules, making FAD+ in the second protein.
As the electron passes through each membrane, they use an active transport to push hydrogen molecules up the concentration gradient using active transport. Then it's given into the inner membrane space and they get to the final protein in each chain. The final electron acceptor electrons are dropped off by oxygen, which then uses hydrogen from passive transport to become H2O.
Meanwhile, here's a better understanding of what the hydrogens were feeling during their active transport.
The hydrogens from the matrix go up through the proteins through active transport.
Here's the rest of the process. After the proteins have moved enough hydrogen molecules to the intermembrane space, ATP synthase will then use passive transport to pull hydrogen molecules down the concentration gradient, producing ATP from ADP. From this process, about 32 to 34 ATP molecules are made.
And that is chemiosmosis. The inputs per glucose for this reaction are 10 NADH, 2 FADH, 6 O2, and 32 to 34 ADP. The outputs for this reaction per glucose are 10 NAD+, 2 FAD, 6 H2O, and 32 to 34 ATP.
This will then combine to the other ATP made in previous processes, making 36 to 38 ATP for living organisms.